Hello and welcome. This demo will focus on how to use ANSYS Workbench to parametrically update ICEM CFD hexam models. You can see in this case I'm looking at the ANSYS Workbench project page, and I've got a missile project loaded, and attached to that is a design modeler geometry. I could also attach CATIA geometry or Pro-E geometry or UG or SolidWorks or Solid Edge or any of the CAD packages that connect to ANSYS Workbench. Let's double click on this to view the geometry. Now here's the geometry that's popped up. You can see it's a missile. This is a very standard type of geometry. The angles, of course, change from design to design, but generally it's very standard Sidewinder missile. This is a parametric CAD design, similar to what you would find in Pro-E or any of the other CAD packages I mentioned. And you can see when I look at the sketch planes, that I still have access to all of the parameters that were used in this design. You can see here V6 is the width of the tip of the rear fins. H7 is the length of this fin. I can make changes to these and mesh this model. So we're going to start with this as our base model. To mesh it in ANSYS ICEM CFD, I proceed to the Advanced Meshing tab. It comes up quickly, and now it's attaching the geometry. And here's our CAD. We'll expand the tree, display the surfaces. Let's turn off the outer region and you can view the missile. So here's the CAD inside Advanced Meshing that matches the missile in Design Modeler. Now normally to hex block this, I would go to the Blocking tab. I would create a block, bounding box around that outer volume. I would then proceed with a series of split blocks, associate blocks, and deleting blocks until my blocking structure fit to this missile. I would then go through and adjust the pre-mesh parameters to make sure that the mesh sizes flowed nicely, and so on. Now I've already done this, so instead of going through that whole process, I'm simply going to open the previous blocking, missile.block. You see here are all my edges. And let's generate the mesh. Expand the blocking branch and turn on the pre-mesh. Mesh is currently out of date. Recompute, yes. And let's turn off the edges so we can view our mesh more clearly. Turn off the surfaces also. And shaded wire these mesh. Now you see it's a nice mesh with lots of good transitions. For instance, the element size here is the same as the element size here. And the element size here is the same as the element size here. Now this isn't just by accident. Let's go look at those edges, the pre-mesh params. And you see that the spacings are linked. So on this edge, I've linked the spacing 1 to the adjacent edge, just simply by checking this box and then selecting the edge. And I've linked spacing 2, which is this end, to this edge, simply by checking this box and selecting this edge. So this is the only thing that I need to do extra. Actually, it's not even necessary, but it just ensures that if this fin moves, the mesh sizes will maintain this very nice uniform transition. Alright, now let's also take a quick look at a cut plane. I'm going to right-click on Pre-Mesh and turn on a scan plane. Mesh is out of date, recompute, yes. This brings up the scan plane window. I'm going to turn on the second scan plane. Make it solid so we can see what we're looking at. Okay, it's not quite through the center of the missile yet. We'll adjust it so that it is. And you can see that the scan plane reveals that there's a nice boundary layer that wraps all the way around our model, over the fins, and around the backside and so on. We can easily adjust the number of elements in this boundary layer so that we can capture whatever boundary layer effects or Y+ we need. We can adjust how far out from the surface it goes. These are easily adjustable with the tools that are in the Blocking tab. Let's turn that off again. And now let's go for the interesting part. Go back to Design Modeler and make some changes to some of these parameters. For instance, let's look at V6, which is currently set to 150 mils, and we'll change that to 200 millimeters. And you can see the sketch updates. Let's also change this H4 from 350 to 400. And again, the sketch updates. Now you can see the sketch is completely out of alignment with our model. So let's just regenerate to make them fit. Now let's change the body tube. That's on a different sketch, so we have to go back to the tree and change to sketch 4. Now we can see that H13 is the radius of the tube. So let's change that from 50 mils to 55 mils. And let's also make the nose cone a little blunter. This is angle A15 is the angle that this is bent down. So let's increase that angle from 195 to 200. And we'll regenerate. And this makes our model blunter and fatter. We could make other changes. We could change, as long as we don't change the schematic. In other words, I can change any of these dimensions as long as I keep 4 fins on the back, 4 fins on the front, and there's this kink halfway along the fin. Or I guess I could straighten that out. But I couldn't add a second kink or change things beyond the schematic that the blocking has already captured.